and today I'm going to talk about Tempdb space usage. Tempdb is a system database inside SQL Server, and it is used by SQL Server for internal and temporary operations. It's a great database. A lot of good things can be done with this, but there are a lot of bad things that can happen with Tempdb. And the most common question that I see in forum, and typically DBAs do a lot of troubleshooting with the size of Tempdb, the growth and the space consumed by Tempdb database. As I mentioned before, that it is used internally by SQL Server to store a lot of temporary data. If we have a good understanding of what is being stored and why it is being stored in Tempdb, it really helps in troubleshooting Tempdb performance. In my demo, I am going to show you an output, something which is similar to this screenshot. And you can see that I am currently looking at Tempdb data size. So let me just take the pen highlighter here. And you can see that a Tempdb here has a data file and a log file. And right now the size is pretty low, which is just like, the default 8 MB out there. And the available space is in is just 4 MB and 6 MB. Now, in the demo, I'm going to run a lot of different types of workloads, and you will see that this 8 MB, which looks like so less and so low, will run into GBs, and you will see that we will hardly have any space available. And typically in production environment, what happens is Tempdb data file and log file, they would generally go on dedicated LUNs. What I mean by LUN is the logical drive. And if there is not enough space, of course, you're running out of space, and SQL Server will then not be able to function properly. And the last thing that you want is your production SQL Server should run uninterrupted. Now, when you are troubleshooting Tempdb, you can see that Tempdb objects are kind of classified as user objects, internal objects, and version store. Now, this understanding is important. User objects are objects that are created by our stored procedures, queries, and workloads. These could be like local and global temporary tables. Internal objects are created by SQL Server for its internal purposes. For example, if your query has a sort or a hash operation and it needs quite a bit of space to complete its job, it can create internal work tables, and this size represents that. Version store, the most common thing, the most common feature that comes to my mind is the snapshot isolation level, where multiple versions of records are being maintained. So that version store is also stored in Tempdb. So I am going to show you a demo on to track Tempdb space usage using two sets of DMVs and how you could monitor it. And then I will run a set of workloads, and I will show you how each of these different types of objects consume space, which can overall increase the size of Tempdb database. Let's jump to demo. Let's get started with the demo. I am going to use DMDB file space usage and a system catalog database underscore files to get this output that I showed you in the PowerPoint presentation. So if you look at this output, we have the Tempdb data file and the log file, and currently you can see that both of them are sitting pretty low at less than 100 MB each, but you have quite a bit of space available again, which means irrespective of what the file size is, about more than 90% of the space is available. And that is because if you look at the output on the top here, user objects, internal objects, and version store are hardly using any space at all. So these are the these are the two DMVs that this is the DMV that I'm using, DMDB file space usage. And of course, when it comes to anyone, if you have ever troubleshooted Tempdb, you would know that this DMV is very critical. And this DMV has some of these columns like internal object reserved page count, then version store, then unallocated extent, etc. And of course, the user object reserved page count. And then we do a bit of mathematics to get the kind of output. Now what I am going to do is run a few workloads, and I will keep coming back to this query, and I will keep monitoring, and I will see that the Tempdb data file size will keep growing, and available space will also keep constantly will keep coming down. And then we will see where is the space being consumed. Is it being consumed by user objects, the internal objects, or the version store? So for the purpose of running these simulated workloads, let me go ahead and create a stored procedure called sp populate data, and that is just for the purpose of demo. You should not try doing all these things in your production environment. You should try to play around with this in your test or dev environment. Now, once the stored procedure is created, I'm going to another query window and a lot of code here. So let's go and start with the first one. So in the first one, I am trying to show you the space usage for our user objects. And let's say in our database, irrespective of which database you create this, you are creating a global temporary table. So I go ahead and create this global temporary table, and you know that the global temporary table is going to be created in Tempdb. Now, if I just switch back for a moment to this one, you can see that user object is at 1536 kilobytes, and this is not increasing right now. The moment I start adding some data to this, so use Tempdb, and I'm going to use the stored procedure to insert some data in this global temporary table. And while this is running, and let me go and run the monitoring script. And now if you keep an eye on the user objects, you will see it's increasing from 4 to 7 MB to 8 MB to 9, so on and so forth. So I think the query is done, and now you can see the space has increased to 9 MB. Now, there's one thing that you will notice, that user objects has gone all the way to 9 MB, but and the data file size is still at 72 MB because you had enough space available in the data file to be consumed. So the data file size need not be increased. If let's say, just to make it a little bad or worse, I will just add another 0 there, and I'm just trying to increase, insert more and more data. And now when I run this and I go back, and let's go and keep looking at this, and now keep an eye that user objects is of course increasing, but at the same time the available space in MB, that is decreasing. So now you will see the available space is less than 50 MB, and at the same time user objects is has grown over 20 MB. So this is really what happens is, as you consume more and more Tempdb, you store more and more data in Tempdb, you will see the space going less. But also observe that the total size, the data file size, has still not increased, because we still have available space available there to be consumed. So let me go and stop this for the time being now. At some point what will happen is the available space will hit the 0 mark, and then the data file needs to be grown, and then the auto grow will kick in and the data file will grow further. Now so this is this was a quick demo on how you can see the user objects section there is growing inside Tempdb, the space that is reserved for temporary objects that your workloads are creating. And we manually created a temporary table and we were inserting data into it. Now let's go back into the code, and now let's see some internal objects. So I have a simple query there, and I'm just going to do some cross join and run this in a while loop. And while this is running, I will see that internal objects, which is right now sitting at 448 kilobytes, will of course start growing. And I think now what's going to happen is that you actually for that sort operation, you can see there is going to be a multi-level sort here. For this sort operation, this space of 448, of course, a work table is going to be created, and this available space here, 22 megabytes, is not going to be enough. So to hold that temporary sorted data, the intermediate results of the sort operations, you will need a work table, and the data file size is going to grow now. So let's go and execute this query now, and while it's running, I will go back here and let's go and see. Internal objects has gone to 960 kilobytes, and let's see and wait for some more time, and there you go. Now it is 49 MB, and you can see Tempdb has gone to 136 MB. So the Tempdb has kicked in, and again as we keep running that in a loop, you can see because we are running it in a loop, so that the internal work table is being consume. So not much there, but you can see there was some increase. Let's go back and let me stop this workload and let's make it a little worse. For example, why not pressurize Tempdb a little more, and we can say c dot number there, and we'll say descending. Now this is going to go even worse, and the temporary result set of that intermediate result set of the sort operation is going to be quite big. And now you will see that hopefully this will go even beyond a GB maybe. So let's wait. Yes. So we are going now. You can see Tempdb is going to touch 500 MB. So just keep an eye on the total size. Now it's going to go even beyond a GB. And what's interesting to note is the available space. At some point I was able to see that, see, look at the available space is just 1 MB because it's constantly growing. Tempdb is constantly growing, and all this is being used by this intermediate result set of the sort operation. So this is the query engine requiring that much space to complete the execution of the query. So this is quite a big there, and you can see the Tempdb data file has grown, it's touching 3 GB now. So yeah, it's more than 3 GB now, and available space is of course pretty less. Now the most interesting thing is, while that workload is constantly running, and you can see it's gone over 4 GB. Now let me go and just stop this query. Now you will observe an interesting aspect. So let's pause here for a moment, and you can see that the Tempdb data file size is close to 4 GB. Available space is of course just 3 MB because the space was being used as it was available. And you can see internal object here is also consuming close to 4 GB. But now that workload has stopped, which means when the workload is stopped, when that query is stopped, do we really need that work table again? No, we don't need it anymore, right? So because the query has stopped, or it has completed its execution, or even if it was cancelled, that work table is of no use anymore because that session is gone. So let's go and execute this, and you will see that internal objects is back to a very low value. Total size of Tempdb is close to 4.6 GB, and look at this, the available space is 4.5 GB, which means now the data file size, the size of the data file of Tempdb will not come down automatically. Either you got to shrink this manually. If you want to recover space on the disk, you will have to shrink this manually, or if you restart SQL Server, which may not be a good idea in the production environment, Tempdb will reset itself to the default values, because as you know, Tempdb is a throwaway database. Anything inside Tempdb is discarded and the space is recovered, and it resets back to the default size of whatever you have set it. But otherwise, this 4.6 GB is not going to come down automatically. But you can see now that if let's say if I go back and run the same workload again, will it grow beyond 4.6 GB? No, it will not, until and unless this available space is not being used. The data file size will not grow. So there we are. I just gave you a quick demonstration of how internal objects can, exponentially grow the size of Tempdb data file. And in most environments, this is what I see. It's not really much the user objects. Typically, I have seen if you're using snapshot isolation, the version store is being used heavily, and I'm just going to give you a demo of that. And in many cases, most cases, I see that internal objects, all these expensive queries with expensive sorts and hashes, they consume a lot of space in Tempdb. And these queries are like, they come, they run for some time, and they go away, and their job is done. But the Tempdb sits at this increased file size, and you got to do something about this manually. It will not come down automatically. Let me quickly show you the version store now, friends. So let me go back to the last piece of the demo. For me to show you the new isolation level snapshot so that it can consume version store, I'll just enable read committed snapshot on AdventureWorks 2012. I have enabled read committed snapshot, and let's go back to the query there and see that version store is 0, which means of course it's blank, it's empty, nothing is stored in version store as of now. And let me open, no, I can run this in the new query itself. So I'm going to create a table and insert some value. Even that's not required. I'll skip that because all I need to do is read committed snapshot is enabled, which means now if I try to okay, let me create this table. I will have to create this table because I'm using that in the query. So let's go ahead and create that table. So now read committed snapshot here means that the default isolation level of SQL Server is read committed. And when we say read committed snapshot is enabled, we have actually enabled snapshot behavior in some ways, which means if I create a transaction and I'm updating inside a transaction, the last committed record, the last committed values are going to be stored in the version store. So just for the sake of demo, you can see version store is sitting at 0 here. And if you look at version store, if you want to see all the records in the version store, you can use this dmtran version store. And if I execute this, you can see that it's blank, it's empty, no record exists there. Now let's go and begin a tran, and this is going to be an in-flight transaction. I'm not committing, I'm not rolling back. So let's just do a small update there. One row affected. Now if I go and look into the version store, you will see that there is one record, and this one record is the last image, the last committed image of that record, which is like in this value stored here. And if I go back to the Tempdb query, and if let's go and execute here, you will see now 64K is being consumed. So that one image of the record is consuming 64K. Now that's how the version store is being used. And now you can imagine if you run a mass update, which is something like, updating like say millions of records, you can imagine and you can do the mathematics yourself. How much space would you really need in the version store if you have to store the last committed value of every record in that batch update? Now let's go and roll back. When I roll back, of course, now this particular session does not need a reference to that image, that version that was there in the version store, and garbage collector will run automatically, and in some time, maybe in a minute's time, you will see that this record from the version store should go away. So let's just wait for a few more seconds, and I'll continue to execute. And till the time this record is here, of course, version store. Okay, there you go. Version store is back to 0, which means this record is gone. Okay, and the version store is now clear because we rolled back or committed our transaction, and the reference to the old version was not required anymore. So in this demo, I did show you how you can monitor and kind of in your troubleshooting endeavors with Tempdb space usage, get an understanding of where exactly is Tempdb eating up so much space. Is it the user objects? Are there a lot of work tables being created by your queries and workloads, which are like they come, they conquer, and they go away, and the space lies unutilized? Or is it the version store? Also keep an eye on the fact that your Tempdb data file size is quite big, but then at the same time, a lot of space is also available in the Tempdb data file. Well, then thank you very much for your time for watching this video. I hope to meet you again soon in another video.